So let's take a look at recursion and what recursion means. We're going to start simple with a simple example with a Fibonacci sequence, which looks like this. So basically, each number is in the Fibonacci sequence is the sum of the previous numbers. Next number being 13 in this case. Now let's write our small function, which takes only one argument. And one important thing when dealing with recursion is to define the base case. In our example, we can see that the first two numbers in the Fibonacci sequence are 1. Therefore, if the argument is smaller or equal to 1, we're going to return 1. Otherwise, we're going to call our function for the previous numbers, right? Because the current number is the sum of the previous ones. So it should look something like this. Now let's see if we can correctly generate a Fibonacci sequence for, let's say, first 10 numbers. Okay, now line 6 to 12. Let's see how it looks. So we can see that we correctly generated a Fibonacci sequence. So we have 13, 21, 34, and of course 55, because that's the next number, 21 plus 34. Another nice example to demonstrate recursion is factorial. We know that 0 factorial is 1 and 1 factorial is 1, and basically a factorial is the product of all positive integers up to that number, including that number. So 3 factorial looks like this. 4 factorial is 1 multiplied with 2 multiplied with 3 multiplied with 4. And we can spot a pattern in here, which is actually 4 factorial is 3 factorial multiplied with 4. Let's define our function. Takes only one argument as well, and guess what? We're going to have the same base condition for our recursion base case, sorry. Why? Because 0 and 1 factorial are 1. Otherwise, we're going to do a recursion and call our function for the previous number and multiply it with the current one, right? Let's see how it looks for the first 10 numbers as well. So it's fact of I. Oh. We need another one, and here 16 to 23. Let's see how it looks. So we can see that we correctly generated the factorial for the first 10 numbers. So we have 24 for 4 factorial, 5 factorial is 120, is 24 or 5. Now another good example for using recursion can be sorting numbers. We're going to sort a list using QuickSort, because it's a nice way to demonstrate recursion. Of course, our base case, if the length of our list is smaller or equal to 1, we're going to return the list. Otherwise, we're going to define our pivot, which is going to be the first number in our list, and then we're going to define two lists, the ones which contains the numbers greater than the pivot. We're going to use a slice and start from the first element, the second element. So if the numbers are smaller or equal to our pivot, then of course let's call it this smaller and this greater. And of course here we said that we want the elements which are greater than the pivot. Now we're going to use recursion to call the function for both lists and of course concatenating with the pivot and here we're going to have greater. Now let's generate a random list. Random with numbers between 1 and 100. Random int. Let's take 8 numbers. Okay, so we need to close this. Now let's see if we correctly sorted. So we have 26 to 40, and normally we should have a sorted list. And of course here we forgot about the condition. So here is if I, and here if I smaller than our pivot and if I bigger than our pivot. So as we can see, this is our first list, the random generated one, and here we have our list sorted. So this is a very simple use case for recursion with 3 examples, and that was it.